Hello, I'm Matt Feller, PhD student at the University of Virginia, working with Julie Bergner, graduating in the spring. I'm interested in homotopy theory and category theory. In particular, I'm interested in model categories, simplicial sets, and higher Siegel objects, which are also the main ingredients we need to talk about to say what quasi-2 Siegel sets are. So let's start with simplicial sets. The way to picture a simplicial set is as being built out of simplices. So you have vertices, you have arrows, you have triangles, you have tetrahedra, and so on for higher dimensions. A more precise definition is that simplicial sets are contravariant functors from the simplex category to the category of sets. So what is the simplex category delta? Well, it has objects, which are finite linearly ordered sets, like indicated, and then the morphisms, which I haven't indicated, are monotone maps. And so one of these objects here from 0 to n gets sent to the set of n simplices of our simplicial set X. So often we view simplicial sets as being like categories by thinking of the 0 simplices as objects, the 1 simplices as morphisms, and then higher simplices as given by composition of morphisms. And so a simplicial set that actually behaves exactly like a category is one that satisfies what's called the Siegel condition, or the one Siegel condition, which says that when you have n arrows like this, that they uniquely extend to an n simplex. So a 2 Siegel set is a simplicial set that satisfies a 2-dimensional version of this condition, where we have 2 simplices attached together in a certain way and extending to n simplices. So for example, these extend to 3 simplices. These pictures extend to 5 simplices, which I haven't drawn. And the way to think of 2 Siegel sets is actually a lot like categories. We still have morphisms and everything, but they are a weakened version where those morphisms don't necessarily compose, or they don't compose uniquely, but that composition is still associative in a certain sense. The notion of associativity comes from these pictures, which show the 2 different orders that we could compose 3 arrows in, and we get the correspondence by the unique 3 simplex that each of these extends to. The most important examples of 2 Siegel object is Mulhausen's S-dot instruction from algebraic K-theory. So you can input actually pretty general things into this, but I'm going to stick with abelian groups for now. When you do that, your simplices look like this, where you just have diagrams of abelian groups. The horizontal maps are injective, the vertical maps are surjective, and each of the squares is both a push out and a pullback. So there's a few things to say about this. So one is, notice with these 1 simplices that these maps to and from 0 aren't really adding anything. All we really have is just a choice of abelian group. Then for a 2 simplex, well, we really just have a short exact sequence of abelian groups here. So one way to interpret this is that our morphisms are abelian groups and our composition is given by group extension. Now, of course, group extension isn't unique, so we don't really get a category here. We don't get unique composition, but we do end up getting a 2 Siegel object. What the 2 Siegel condition amounts to here is saying that this 3 simplex diagram would be determined by everything except for either the A20 object or the A31 object. So, for example, if we were missing this object in this diagram, so we still have this arrow, but we don't have this object or the arrows to and from it. Well, can we recover the data of the whole 3 simplex diagram? And we can, because we can take a pullback here, and then we get a unique induced map here, and you can check that all the stuff that needs to happen happens. And so everything works out. But there's a little bit of a subtlety here, which is that this is really only unique up to isomorphism here when we take a pullback here. So we don't quite get the two-Siegel condition satisfied if we think of these as simplicial sets. So instead, you have to think about this as a simplicial groupoid. So instead of a set of simplices, you have a groupoid of n simplices. So moving from sets to groupoids is one way to get a looser version of something. So we saw earlier that Siegel sets were essentially categories. You can get a looser version in Siegel spaces. And you can do the same thing with two Siegel sets. This is the traditional approach in the two Siegel literature. And in fact, most of the two Siegel literature focuses on two Siegel spaces instead of on sets. But with categories, Siegel spaces aren't the preferred place to work. There's been a vast development of theory of quasi-categories thanks to Joyal and Lurie. So you might wonder, is there something similar for two Siegel sets? Can we work within simplicial sets themselves and just weaken the condition instead of kind of broadening the target category? And an example of this should be what we were talking about earlier, except without using, changing to groupoids. We just take S-talk construction with a set of simplices, as we were describing. And so this is what I tackle in my thesis. I come up with a good notion of quasi-two-Siegel set, and in particular, show that it has a corresponding model structure on the category of simplicial sets. So let me just finish off by saying a little bit about model categories. So basically, the fact that quasi-categories have this associated model structure on simplicial sets, called the Joyal model structure, it gives quasi-categories kind of a robust notion of homotopy theory to go along with them. And the tricky thing about it is that, well, it's not so bad to start with a model category and then just add more weak equivalences. This is a kind of a straightforward way to get new model structures. And there's plenty of different model structures in the literature along these lines. But to get a quasi-two-Siegel set model structure, we would need to go the other direction. We would need to have fewer weak equivalences. And this is a lot more open-ended. So my strategy was to use Szynski's powerful machinery to explore what's possible for different model structures with fewer weak equivalences than the Joyal model structure. And in a paper that's going to be on the archive pretty soon, I kind of map out this situation here, minus the quasi-two-Siegel part. That's going to be later. So in particular, I identify this minimal homotopically behaved model structure. And this corresponds to simplicial sets that have a homotopy theory that's similar to quasi-categories, but they don't have this kind of like composition from, gives them the categorical behavior. And so it's sort of a good starting place to then work and introduce the kind of the two-Siegel things to get quasi-two-Siegel sets. And I think that's all I'll say for now. Thanks for watching.